Aloha everybody. I am Riley Sokol, and this is my upcoming undergrad senior thesis project on coral recruitment. So I am focusing on coral reefs because they are a huge ecological significance. Coral reefs are essential ecosystems. They fix large amounts of carbon dioxide, largely due to corals and their endosymbiotic photosynthetic dinoflagellates. This makes coral reefs one of the most productive ecosystems on the planet. Corals are also ecosystem engineers that support the most species-rich marine ecosystems by providing complex habitats through the creation of reef-building calcium carbonate skeletons. They also play an important role in food security, sustaining 500 million people in over 100 countries. And lastly, they help us economically, generating an estimated $375 billion US per year. Unfortunately, these valuable ecosystems are under many pressing threats, like coastal development, which causes habitat loss, and pollution from anthropogenic sources like runoff from cities and farms, and also overuse, like overfishing, which disrupts important species services that fish provide, like grazers, taking algae off of corals. And then they also are under threats from different effects of climate change, like ocean acidification, which weakens corals' calcium carbonate skeletons, and then also damages their tissues, and then elevated ocean temperatures, which make it harder for corals to carry out their biological functions. To deal with these threats, scleractinian corals use the many adaptive mechanisms that have allowed them to survive and be the dominant reef builders for the past 65 million years. They can change their morphology in response to changes in their environment, like light energy and wave energy, and they've developed mutualistic relationships with symbiodinium, which allows them to get energy through photosynthesis and heterotrophic feeding, and they have developed multiple reproductive strategies suited to different conditions, which allows for genetic diversity. Among these strategies are gonochoric spawning and hermaphroditic spawning, where corals broadcast spawn gametes or self-fertilize and broadcast spawn, which allows for a larger larval dispersal range and recruitment to corals to near and far habitats, allowing for growth or maintenance of a reef. Because of this, recruitment plays an important role in reef health. Recruitment can be an indicator of reef health and allow people to predict the trajectory of reef growth or decline and inform conservation strategies. If recruitment rates are low, it can be a sign that a reef is in health decline, and if recruitment rates are high, it could be a sign of a healthy, thriving reef. Understanding recruitment at a given reef could also give us information on how well our reef could recover after disturbance events, such as bleaching events or storms. Overall, it is very important to study recruitment here on the Big Island to gain valuable information on our reefs that could aid conservation efforts. Given the importance of coral recruitment for reef health, I aim to fill some gaps in our knowledge of what is recruiting on some of our reefs here on the Big Island and see what the implications are. I plan to do this by placing recruitment tiles, most likely at Keohole Point and Laihala, and using fluorescence to identify the abundance of the early recruits on the tiles, and later identify the species of the recruits on the tiles, and use 3D models of the chosen reefs to compare what is recruited to the tiles to the current coral cover of the reef. Through this project, I hope to gain a better understanding of our reefs on the Big Island that will contribute to management and conservation efforts. Mahalo for listening in your time. Any questions? Oh, Kristen?
Have there been any previous studies of recruitment in this area?
I am not sure. I haven't gotten too far into the literature research yet or started much of the project yet, but I'm planning to do a lot of review on that and see what people already know about in the area.
What are recruitment tiles?
Recruitment tiles are basically like blank slates that you put down in a reef that allow different things to settle on it. So it's basically like your own substrate that's like your controlled substrate, so you can see what it comes to like brand new areas on a reef.
Do they have the same kind of material or texture as the ocean bed would have, such that the waves aren't going to push things off of it that wouldn't get necessarily pushed off of a more complex substrate?
Yeah, there's lots of different kinds of like recruitment tiles that have different like textures or even made out of different materials. So I'm also planning on doing some research on that to see which ones I should use for my project. Thank you.